Okay, dual college algebra enrollment. Welcome to the final 4.3 is the last lesson in Unit 4, short unit. Applications of systems of equations. We know what applications means. It means word problems, right? You remember that? All right, so we did a whole section on word problems in Unit 2. We're gonna see a lot of similarities. In fact, some of the strategies you used in Unit 2 can be used to solve these, but using the idea of creating systems to solve equations sometimes will make the problem easier for you, okay? So what you need to do is identify a variable. You need to make, from your information, you need to make as many equations as you have variables. So if we have 2 variables, we're getting 2 equations. If we have 3 variables, we're gonna need 3 equations, and so on. And then you can solve these equations or these systems of equations using any method. Take a second to write that down. I feel like you have it by now. I can always pause it. So we did problem some of this in Unit 2, similar to this, but we're gonna take a slightly different view at it. Instead of using 1 linear equation, we're gonna use 2. A rectangle is 42 feet longer than it is wide. The perimeter is 228 feet. What are the dimensions? Okay, so we have a rectangle, and we have the length and the width. So we have 2 variables, which means we're going to have 2 equations, okay? The equations are gonna come from this information here. They're gonna come from the 42 feet longer, and they're gonna come from the 228 feet. There's an idea here that I really want you to get to understand, and if you do, I mean, if you have more math later in your life, and you do, or you take the SATs or ACTs and you have a real good understanding on this particular idea right here, it will be so helpful. Let's make an equation from the first statement where it says the length is 42 feet longer, okay? Now, I hope that you can figure, or you remember the word bank that we had with all the different words that mean math stuff? Well, what would you say 42 feet longer than mean? Like mathematically wise, like what are we gonna do with that 42? We're gonna add 42. Longer than is like the same as more than, or we're adding 42. So when I make my equation, I'm gonna start by saying W equals L, okay? Now, we're not done yet, because that's not true. I was just told that it's 42 feet longer than it is wide. So I really want you to understand this. If you can understand this, you get a good understanding of how this works, it'll be so much easier to set up these equations in the future. We know L is not equal to W, that's a lie. In fact, what's bigger? What number would be bigger? The L has to be bigger. But I need to make this statement true. It needs to be a true statement. So what can I do with 42 feet longer in this equation to make it true? Where am I gonna add 42? Keep in mind I have to make it equal, and right now it's not equal. The only way I can do that by adding is if I add 42 to the smaller side to make it true. W plus 42. And always, every year, I'll do it. And I guarantee you this year, so you can ask me, and it's fine. You're like, why don't you add 42 to the L? Well, L is a bigger number. And when I want to make 2 things equal, I add to the side of the equation that's smaller to make it equal. Now they're equal. The other equation is going to be a little easier to set up. Comes from the perimeter. The perimeter is 228 feet. So we have, let's see, for the perimeter I have 1 W, and I'm going to have another W here. And I'm going to have 1 length and another length here. So my perimeter would be 2L plus 2W equals perimeter. But we know the number that perimeter is equal to. Perimeter is equal to 228. Now, what method of solving a system of equations is best to use here? I would argue substitution because L is already isolated. L is equal to W plus 42, and I can take this W plus 42 and replace this L with it, and I would get 2W plus 42. I'm using parentheses when I replace this L. 2W plus 42 plus 2W equals 228. And then I'll distribute and I would get 2W plus 84 equals 2W. I'm sorry, 2W plus 84 plus 2W equals 228. And then if I combine the 2W plus 2W is 4W plus 84 equals 228. And then I'll subtract 84. And then I get 4W, I'm running out of room, aren't I? I'll get 4W equals, I'm gonna grab my calculator real quick. A long day. $228 minus 84. So I would get, I'm gonna continue over here. Right here down at the bottom. I would get 4W equals 144, and then I'll divide by 4, and I get W equals 36 feet. I think that's reasonable for a tennis court. I am not an avid tennis player, but it seems reasonable to me, 36 feet. All right, now, to find the length now, I'm just gonna replace this 36 feet and replace the W with it. So 36 plus 42 is, the length is now 78 feet. Now, if you remember, this was hashtag a geoprob, and we kind of did something like this, very similar, but instead of calling it W and L, we just stuck with one variable, and we wrote the length as an expression of the width. So that's something you can do with these problems, but right now we're just adding different perspectives of the problem, giving you more and different ways to solve these types of problems. Okay, thank you very much. We have one more video for 4.3.